Hello, everyone. We are starting the derivative of trigonometric functions, and we're using the formulas and some examples as well. Okay, so first of all, we should see the proof of one of the formulas, and then we're going to expand the same scenario for the rest. I start with y equals sine u. The reason I'm using u here is because of the combination that I want to explain. But you can start with y equals sine x, and we're gonna find the derivative of this function. I'm using the formula, the basic principal derivative formula, the limit of sine x plus h minus sine x divides by h when h is approaching to 0. So now we're gonna expand the sine x plus h. So this will be sine x times cosine h plus cosine x sine h. Then minus sine x in the top all over h. If you see in the first and last term in the top, we have sine x. So you can factor it out because sine x is not dependent on h. So we factor from sine x, and then the limit of, I'm going to separate this fraction into two fractions. So it's going to be the limit of cosine h minus 1 divides by h when h is going to 0, and then plus in the second term here. So we can factor from cosine, and then multiplies that by the limit of sine h over h. Okay, now we use the actually limit strategies to solve these limits, and then simplify this as much as we can. So we know the limit of sine h over h when h is approaches to 0 is 1. This is one of the theorems that is in the limit section. Also, if h is going to 0, so sine h will be 1. So we're going to have sine x times 1 minus 1 divides by a number that is going to 0. So means it is 0 over a very, very small number, means, for example, 0 over 0.001, which is eventually a 0 value, and then plus cosine x. Sine x times 0 will be 0. So 0 plus cosine x is going to be cosine x. So the answer to this question here is cosine x. But I'm using u here, and I assume that u is another function. Then y prime is gonna be cosine u, we already found that, times u prime. We can use the same scenario for proving the other trigonometric ratio. So if you try the same formula and expand this for cosine u, then the derivative of cosine will be negative sine u times u prime. Okay. And then y equals tan u, where u is g of x, then y prime will be 1 plus tan squared u times u prime. I'm just writing the formulas. You don't need to prove them, but if you want, so you can try the same formula that I use here, the basic principal derivative formula. And I know 1 plus tan squared u is going to be secant squared u times u prime. So for the derivative of tan, there are two formulas here. 1 plus tan squared u times u prime and secant squared u times u prime. Number 4 is cotan, where u is g of x, then y prime is negative 1 plus cotan squared u times u prime. So it has negative sign. And then I know 1 plus cotan squared is going to be cosecant squared. So this will be negative cosecant squared u times u prime. Number 5 is secant. Secant is 1 over cosine. These are the reciprocal trigonometric ratios. So y prime will be secant u times tan u times u prime. Don't forget to multiply by u prime because g of x is another formula and we're using the chain rule here. That's a combination of chain rule and the derivative of trigonometric functions. And number 6, y equals cosecant u. And y prime will be negative cosecant u times cotan u times u prime. So I highly recommend you to take a screenshot of these formulas here, number 1 to number 6. And with these formulas, you can solve almost all the derivatives for trigonometric ratios. We will try some examples in the next slide. Okay, I start with the simple examples and then we have another worksheet to do the combination of, all the functions in place. Okay, for example, we have y equals sine x squared. This s square is on the top of x, is not for the whole sine. So means u here is x squared. If you remember the formula, the derivative of sine u is cosine u times u prime. So now the derivative here is going to be cosine x squared times u prime, which is 2x. Next one is cosine root x. So what is u here? So u here is root x. I'm using the formula y prime is going to be negative sine u and then multiplies by u prime. And how do you find the u prime? So u prime is gonna be 1 over 2 x to the power of negative 1 over 2. I'm using the power rule, and this will be 1 over 2 root x. So now we are substituting u prime here. For example, you have tan 1 over x. What is u here? U is 1 over x. And what is u prime? So this is a quotient. We're using the quotient rule. It's going to be the derivative of the top, which is 0 times the bottom. 0 times x is 0. Minus 1 times the derivative of the bottom divides by x to the power of 2. So this will be negative x over x squared. So now we're using the formula for tan u. Y prime is going to be 1 plus tan squared u times u prime. Or instead of 1 plus tan squared, we can use secant squared u times u prime. Another example for cotan, y equals, for example, x plus 1 times cotan x. Okay, so we're using product rule as well as the cotan formula. So now y prime will be the derivative of the first function, which is 1, multiplies by the second function, and then plus the first function times the derivative of the second function. And we use the formula for cotan is gonna be negative times 1 plus cotan squared x. And just pay attention to u here. U is x, so means the derivative of x is 1 here, so you can skip that. So instead of this part, you also can write cosecant squared x. So the answer will be cotan x minus x plus 1 times cosecant squared x. Another example for secant, for example, we have y equals secant x to the power of 3 plus 2x. It's a sum of two functions. So we need to take derivative of each one and then we add. So derivative of secant u. And what is u here? U is x to the power of 3, and then u prime will be 3x squared using the power rule. So we have secant rule, secant u, derivative of secant u is going to be secant tan. So it's going to be secant x cubed times tan x cubed, and then multiplies by u prime. This is just the derivative of secant, and then plus the derivative of 2x will be 2. And then another example for cosecant, for example, we have cosecant, let's try a squared. Cosecant a squared of 2x minus 1. Okay, what do you have here? So you have cosecant squared, so means here you have cosecant to the power of n, cosecant u to the power of n. So you have u as a combination of cosecant and a new function, and also you have exponent on cosecant. How do you expand this? So we're using the chain rule for n. The power of n means the combination of the power rule and chain rule. So y prime will be, as a formula, is going to be n cosecant to the power n minus 1, and then you multiply by the derivative of cosecant, which is negative cos u, cotan u, and then multiplies by u prime. Okay, please pay attention to this new formula here that has u and n, the power. We're using the power rule and chain rule simultaneously. So means you have to use n, you decrease one exponent from cosecant, and then you take the derivative of the base. And what is the base here is cosecant u, which is going to be negative cosecant u, cotan u, and multiplies by u prime. So now in f, u is 2x minus 1 and n is 2. I'm going to use the same formula, so y prime will be 2. Just decrease one exponent from cosecant, and then multiplies by the derivative of the base, which is negative cosecant 2x minus 1, cotan 2x minus 1, and then multiplies by u prime, which is 2 here. Okay, and then this will be actually negative 4. Cosecant times cosecant will be cosecant squared 2x minus 1, and then multiplies by cotan 2x minus 1. So far, so good so far. So I hope you learned how to use the formula, and these exercises are enough to learn and practice the basic questions you may have here. But we have another worksheet for extra practice that is going to be started now. Now we know the formulas. We're going to apply the formulas for each exercises. Chain rule application, question number 10 to 14. We're not going to solve all. I do some of them, and I highly recommend you to try the rest. And just put comment under the video if you have any questions or if there is something that you're struggling with. Okay, number 10. We have sine u. U is 2x. So y prime will be cosine u times u prime times 2. 11. Y prime equals, okay, we have tan u. The derivative of tan u will be 1 plus tan squared u times u prime. U prime is 3 here. Or instead of 1 plus tan squared, to make it short, we have secant squared 3x plus 1 times 3. Or you can write 3 as a coefficient. It's better to write 3 as a coefficient. 3 secant squared 3x plus 1. Okay, I'm gonna try 13. We have cotan u. Y prime will be negative 1 plus cotan squared u times u prime. Derivative of root x is 1 over 2 root x. We calculated earlier in this video. And then we can just use negative 1 over 2 root x. And then instead of 1 plus cotan square, so we can write cosecant square root x. Okay, from the second series, I'm trying to solve number 16 and number 19. It's a product rule and quotient rule. Y prime will be derivative of the first function multiplies by the second function, 2x times cosine x plus x squared times derivative of cosine is negative sine. So u is x here. You don't need to find u prime, which is 1. And then this will be 2x cosine x minus x squared sine x. We're using the product rule. So for the ones who don't know what is the product rule for derivative, h prime will be derivative of the first function multiplies by the second function plus the first function itself multiplies by the derivative of the second function. And also question number 19, it's about the quotient rule. I'm going to just write the quotient rule as well. F of x over g of x. When g of x is not equal to 0, the quotient rule h prime will be derivative of top multiplies by the bottom minus the top itself multiplied by g prime all over gx to the power of 2. Okay, now we're using the formula and also we have the trigonometric function secant here. So y prime will be derivative of top. The secant x will be secant tan. Multiplies by bottom x squared plus 1 minus derivative of the bottom multiplies by the top. Divides by x squared plus 1 to the power of 2. You don't need to simplify this more, so just leave the answer at this step, unless they ask you the next step or you have the value of x to 7. You can simplify this more with the new values. And then from the question number 20 to 24, it's a challenge section. So we're trying number 20 and number 21. Okay, we have the product rule. F prime will be derivative of sine, which is cosine, multiplies by the second function plus the first function multiplies by derivative of cosine, which is negative sine. This will be cos squared x minus sine squared x. And if you know the trigonometric formulas, this is cosine 2x. Number 21, if prime of x equals, we have the exponent on tan. So we're using the power rule and also derivative of tan. So it's going to be n f to the power of n minus 1. So this n here is 2. So 2 tan with the power 1, and then you multiply by the derivative of base, which is tan. So it's going to be 1 plus tan squared x, and then times u prime. So u is x here, derivative of x will be 1. So if you expand, if you just distribute tan x by each term in the bracket, so you're going to have 2 tan x plus 2 tan x to the power of 3. I highly recommend you to try the rest of questions here. And please add comment under the video if you have any questions or any concerns about derivative rules. Thanks, and see you in the next video.